Welcome to Our Lives, Our Science, featuring interviews with students, faculty, and staff in the University of Minnesota's Department of Biochemistry, Molecular Biology, and Biophysics, or BMBB, under the College of Biological Sciences and the Medical School, sponsored by the BMBB Department's Diversity, Equity, and Inclusion Committee. Our Lives, Our Science introduces inspiring people and briefly explores their life stories in the context of pursuing science. I'm Bob Evans, a postdoctoral fellow in BMBB, today's host for Our Lives, Our Science, and we'll be introducing to you Lidia Limon Swanson, a third-year graduate student and doctoral candidate in the BMBB department. Welcome, Lidia.
Thank you, Bob.
Lidia, tell me a little bit about yourself, who you are and how you got here.
So I am a mom, I'm a wife, I'm a student, I am a Mexican-American scientist. I am many things.
Fantastic. What one word then best describes you? One word.
The word that best describes me is resilient.
Lidia, what has been the most defining moment of your life?
The most defining moment of my life. Okay. I would have to say that moment was when I realized that my lack of legal status would really define my future and what I could achieve.
When did you realize that there would be challenges in achieving your personal and career goals?
I think I realized that pretty young. I grew up always with the reminder that we could be deported and be sent home to a country that I did not grow up in. We had to always be low key and good model citizens and not ruffle any feathers.
Did you ruffle any feathers, Lidia?
I never got caught.
Good answer. So what kind of challenges did you face, Lidia? Give us some specifics.
So I could not plan for college. I there are certain documents that you at the time needed to attend college. Now we have DACA, which is a little different, and that allows students to attend college. I did not have that. So when I graduated high school, I had to find a job, which in itself was a challenge because when you don't have the proper documentation, it's very difficult to find a job.
Hmm. So what motivated you then to push through? I have to imagine. Wow, I had to imagine with these kinds of challenges that it would take a fair amount of motivation. So, what did motivate you to push through?
What motivated me was I was not going to let anything really stop me. I know what I want, or at least I'm pretty aware of what I want in life, and nothing was really going to try or was going to stop my attempt in that, in achieving that.
Hmm.
And I took those challenges in stride, and it really defined who I am now.
So, when did you know that you wanted to pursue a career in science?
I realized I wanted to pursue science when at the age of 12, 13, was actually in the delivery room with my family, serving as the translator. And so being in exposed to that experience, and there was several times in my life very young, and I realized I wanted to be there and be the person that could help women and children and really be present.
Awesome. So, um, how has your path differed from that of a typical college student or a typical graduate student?
So my path is very different. I did not go from high school directly to college. I, in fact, I got married and started my family um, because I was still very limited for until I received my legal status. And so I continued living. And continued living was starting my family, which I knew was important to me. And no document was going to stop me from living my life.
Awesome. And you have an awesome family. I know Lydia's family. Her family is quite cool.
I like to say so.
So, Lydia, what let's speak to perhaps some other students who have maybe are living a similar story or a story where um, they don't quite know what it's going to take from the standpoint of resources to help them get where they need to go. What resources did you rely on, or even continue to rely on today, in order to move forward?
Well, I can definitely say I am not doing this alone, and I have not been doing it alone. I am very grateful to have my family who have always been there to support me, even if they themselves have never pursued science. They are my biggest cheerleaders, and with their support, um, they really pick me up when I'm having a hard time. And that in itself is very key to my success.
Excellent. So, would you say you've achieved your educational goals?
Not yet. I'm working on them. But I also want to mention that I also relied on a lot of scholarships. I relied on grants, and I also relied on student loans. And without those, that's the other piece of the puzzle that really has helped get to or work towards my goals.
That actually brings up another very excellent question, Lydia. Can can you point us to resources for loans and financial aid, grants, and scholarship that you used?
Absolutely. There is FAFSA, which is key in the uh, financial aid that school can offer you. There's also institutional scholarships, and there's also departmental scholarships. There's also a lot of sources outside of the institution, and those are sources that I have been very lucky to have found and applied for, and have been very lucky to get some of those. It's really more about dedicating the time to look for the resources, and they're out there. They're definitely out there.
One thing that I think we might be able to do, Lydia, is when this interview is over, I will flash up on the screen here perhaps some URLs where students who have access to the web can take a look and point them in the direction of resources like you have been describing here. So that's something I can get from you after the interview, and we'll go ahead and put up on the screen for our student watchers here.
Yeah, that's perfect because I really couldn't name a specific one. There's a lot.
Oh,
I
yeah.
mean, there's, yeah, so,
Excellent. Thanks. I think that'll be a big help.
yeah.
So, another question. What what are your goals after completing your degree? Tell me what degree are you again attempting to complete, and what are your goals after you complete that degree?
So my goals are to pursue a PhD in biochemistry, which I'm currently working on.
Hmm.
The future holds multiple possibilities. I have always followed my interests, and that has led me through a nonlinear path that I'm very glad that I am on because, again, it has allowed me to really hone in on my interest and love what I do. So, as of now, I want to complete my degree, and as we all say, I want to work in the industry and I want to do medical research. I'm also interested in becoming a professor, a research professor that would do research and also be involved with students. That's because I really like teaching and helping people understand very difficult concepts. I find that really fulfilling, and I'm on the other shoe right now, and I think it's really great when you have people that are there to support you and are really interested in your best. So I want to be on that side as well. So for now, endless possibilities.
Nice. It's a little bit like paying it forward, isn't it?
It is. It is.
Super. So, Lydia, I know that you hold a special place in your heart for underrepresented minorities pursuing science. What is your advice to underrepresented minorities that are pursuing a career in science or any STEM field for that matter? Give some advice.
The biggest advice I could say, and this is the one thing I make sure to let people know when they ask me this question is follow what drives you, follow what you love. Because if you follow something that does not drive you or that you do not love, when it gets challenging, it's really going to become even more challenging if you don't have that passion for it.
Hmm.
And so for me, I really am adamant about following what I love, which is why my future is open. And the possibilities are endless. I don't know what I might like, and I will figure that out as I go. And that's just part of the path. But definitely stay true to what you are interested in and dedicated on, because there will be tough times, and it becomes easier when you know that you love doing this.
It's excellent advice. Lydia, I want to thank you for sharing a little of your life with us today. Would you be interested? Would you like to share some of your science with us too?
Absolutely. You want to follow me to lab?
Let's go there. Thank you,
Yeah,
Lydia.
you're welcome. Thank you.
Hi, Lydia.
Hi. I pursued science because I find it really fascinating, and I'm going to show you an example of that today. When we think of proteins, many of us think of muscles and bodybuilding, which they are involved in, but proteins are really involved in much more. Proteins are really responsible for most of the tasks in cellular life, and one of our focuses in the Wendy Gordon lab is exploring how these proteins really connect with one another. Welcome to the Pilot Structural Biology Lab. This is the X-ray generator that we use to shoot protein crystals. Without computational enhancement, even the most advanced microscopes do not reveal much structural information. For example, the image on the left is a high-resolution image of multiple proteins. When you take a single protein and magnify it, you can see that very little structural information can be revealed, even by the most expensive microscopes in the world. However, with computationally enhanced methods, we can reveal atomic resolution structures. The four primary methods used are X-ray crystallography, nuclear magnetic resonance spectroscopy, cryo-electron microscopy, and purely computational methods. Today I'm going to talk to you about X-ray crystallography and the types of structures that we can solve at the atomic level. In our lab, for example, we have learned how single-stranded DNA binds to certain proteins at the atomic level, as well as the ions involved and the amino acids interacting with specific DNA bases. A basic overview of the X-ray crystallography workflow begins by isolating a purified protein of interest. We then find conditions in which the protein will crystallize. Once the crystal is obtained, we shoot the protein crystals with X-rays while rotating it along the X-ray beam. We then collect the diffraction data. Here we have a two-dimensional slice of the data. From the diffraction spots and their intensities, we can then compute the atomic structure of the protein as modeled on the right. From the structural information revealed by X-ray crystallography, we can learn valuable information which we can then use in many applications. This is just an example of the really great science I am doing. Won't you join me?